Now we're on page 6 of the AP Chemistry Chapter 5 notes. We're going to be talking about the kinetic energy of gases. Kinetic energy is energy of motion. So a couple of factors are going to affect the kinetic energy of the motion. In this case, it's only temperature for kinetic energy, so as well as the amount of gas. So the hotter a gas, the hotter the temperature, the more kinetic energy that sample will have, and the more moles, the more kinetic energy it will have. So let's say we had a cold gas and a hot gas. The one that has more kinetic energy is the hot gas. Let's suppose you had a bigger container of the hot gas. This third container would have more kinetic energy than this one, and of course this one has more kinetic energy than that one. So it's just a simple formula to find the kinetic energy. Let's suppose we're trying to find the kinetic energy of carbon dioxide at 25 degrees Celsius. We're just going to say it equals 3/2 times R. Now this R is a different R than the other R. This one is 8.31 joules per mole Kelvin. If you wanted to take the time, you could actually derive this R from the other R, 0.0821 liter atmospheres per mole Kelvin. They're actually the same number and unit converted. So this is the R you have to use here to match the units. And now we're going to talk about the temperature, and the temperature is going to be 25 degrees Celsius, but you have to make it into Kelvin. So that's going to be the temperature, and then you're simply going to multiply that and find your kinetic energy. So 1.5 times 8.31 times 298 is going to give you, with 3 sig figs, it would be 3710 joules, and that's going to be the CO2 at 25 degrees. The interesting thing is if you did this calculation for hydrogen instead of carbon dioxide, you'll be amazed that you would have the exact same answer, because the identity of the gas was not as important. It was only the temperature and the moles. Okay, so this one, I forgot to write a times 1 here. This one is also going to be a times 1, and that's going to be the same answer. But now if you want to find the kinetic energy for 2 moles of hydrogen, it would be the same beginning part right here, but then you would multiply it at the end by 2 moles. So that would be double, which would be 7420 joules. So you see that only temperature and amount of gas affects the kinetic energy of a gas. Now we're going to shift gears to talk about the root mean square velocity, which has to do with the speed of a molecule. The speed of a molecule. So in order to understand this, let's just take a quick analogy of a car and a truck. So here's a car, and here's a truck. If they're both traveling, and they each want to knock down a wall, same wall, the car weighs a lot less than the truck. So the truck could be moving at a slow pace, but the car would have to move at a faster pace in order to knock over the wall. So you could see that the same amount of energy will knock over the wall, whether it's a truck or a car. The energy is going to depend on the mass of the vehicle and the speed of the vehicle. So a small mass and big speed is the same as a big mass and a small speed. So there are 2 factors that affect the speed at which particles move, which is going to be